I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Okay, so let's go to binary subtraction. So again, binary subtraction is performed in the same manner as that of your decimal subtraction. Okay? So we have here again a table for your binary subtraction. You have 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 0 minus 1 is equal to 1 with a borrow of 1 on the next digit. Okay? So let's try to use this table here with our example number 1, or using our example number 1. So you have 10101 minus 1110 of base 2. So let's say 1 minus 0, the answer is 1 minus 0 is 1, no? Based on our table. Okay? Then 0 minus 1, the answer is 1 with a borrow of 1. So this one here, 0 minus 1 is 1 with a borrow of 1 here. Okay? So this one here becomes 0. Alright? Then 0 minus 1 again is 1, and we need to borrow here on the next digit. So this 0 here, which is the next digit, becomes 1. But since this is 0, it needs to borrow again from the next digit, which is 1. So this one here becomes 0. So 1 minus 1 is 0. Bring down 0 of base 2. That is binary subtraction. So for checking purposes, okay, so let's say, what is this binary number equivalent into decimal? So you have 1, 2, 4, 8, 16. So 16 plus 4 is 20, plus 1 is 21 of base 10. And this one here is what? 1, 2, 4, 8. 8 plus 4 is 12, plus 2 is 14 of base 10. No? So we subtract. So you have 1 minus 4, so you have to borrow. So this becomes 11. This becomes 1. 11 minus 4 is 7. Then 1 minus 1 is 0. So that is 7 of base 10. Okay? And this one here is what? 1, 2, 4. 4 plus 2 is 6, plus 1 is 7. So in other words, this binary number here is equivalent to this decimal number. Okay? So that's how to subtract a binary number. Okay? So let's say we have example number 2. We have 1110.01 of base 2 minus 1011.10 of base 2. Okay? So we make use of the table. 1 minus 0 is 1. 0 minus 1 is 1 again. But since this is 0 here, we'll have to borrow from the next digit. So since this is 0 again, this becomes 1. Okay? Now, this 0 here needs to borrow again in the next digit. So this one here becomes 0. Alright? Then, you subtract 1 minus 1. Bring down, by the way, bring down the binary point. 1 minus 1 is 0. 0 minus 1 is again 1. Again. Then, needs to borrow on the next digit. So this becomes 0. Then, 0 minus 0 is 0. 1 minus 1 is 0. That is, the answer now is this one. of base 2. Now, if you want this check, okay? So you have 1, 2, 4, 8. 8 plus 4 is 12 plus 2 is 14 again. 14 point what? 0.5 and 0.25. So 14.25 of base 10 minus this one here is 1, 2, 4, 8. 8 plus 2 is 10 plus 1 is 11. 11.5 of base 10. No? So we subtract. So 5 minus 0 is 5. You have 2 minus 5, so this becomes 12. This becomes 3. So 12 minus 5 is 7, right? Then 3 minus 1 is 2. 1 minus 1 is 0. So you have 2.75 of base 10. So is this number here equivalent to this number? So let us check. So this is what? 0.5, 0.25. This is 1. This is 2. So you have 0.5 plus 0.25 is 0.75 of base 10. Okay. So in other words, this number here is equal to this number here, which is in decimal form. Alright? So the technique here is that the borrowing will continue until such time that a 1 is encountered. Once, for example, in this case, 0 minus 1 is 1. Okay? Then, it needs to borrow from here. So, since this one here is 0, so we have to find a 1 so that the borrowing will be justified. No? So, this one here will borrow here. So, this becomes 0. And then this becomes 1. So, since you encountered a 1 here, then you stop. Then you continue the subtraction. Now, since this becomes 0, okay, it needs to borrow again here. So, this becomes 0. Okay, and then continue the subtraction. So, you have 0 minus 1 again is 1. Then, this becomes 0. 0 minus 0 is 0. 1 minus 1 is 0 of base 2. That's how subtraction is performed in this particular values. Okay? So, let's have another example. Example number 3. Say you have 1,0,0,0,1,0,1.110 of base 2. We want to subtract this with 1,110.001 of base 2. Okay? So how do we do this? How do we subtract? Again, 0 minus 1 is 1. You need to borrow here. This becomes 0. Okay? So, since naka-encounter kang 1, stop. Then, 0 minus 0 is 0. 1 minus 0 is 1. Bring down the binary point. 1 minus 0 is 1. 0 minus 1 is 1 again. This becomes 0. Okay? Since this is 1, mag-stop o borrow. Then, 0 minus 0 is 0. Then, 0 minus 1 again is 1. Mubaro ni siya diri. So, this becomes 1. Mubaro ni siya diri. This becomes 1. And mubaro ni siya diri. This becomes 0. Since you have here a 1, so you stop the borrow. Even if it is already the last number. No? Then, you continue the subtraction. 1 minus 1 is 0. 1 minus 1 is 0. And then 0. So, that this will be your binary equivalent of the numbers, this one subtracted with this particular number.